Is the slides visible to you?
Yes, sir.
Oh, that's great. So I was in my last session, I was talking about differentiation. So I just recall you what differentiation was, because differentiation is a wide has wide applications, but I will start it today's session with the last part of the differentiation there, where we cannot we don't have numerical numbers in the power of the function. Here you can see that there are two things, two functions basically. Y is equal to fx raised to the power gx. Gx means that is a function, and fx is again a function. In that case, where anything apart from a number, 1, 2, 3, 4, 5, 6, if anything is there apart from the number, we have to apply logarithms. In that case, what is the method? The question is y is equal to fx raised to the power gx. We will straight away apply natural log on both sides. You will see log y is equal to log fx raised to the power gx. When we will get a function in this position, then we will apply the property of log. That is, you can see in the next step, that is log y is equal to that gx which was in the power has been brought in front. Now it is gx into log fx. Now the question arises why. You can see there are five properties of logarithm given below the slide. That is log mn, two things in product. Then that is equal to log m plus log n. Second one, anything in division, log m by n is equal to log m minus log n. The third one is that case what I did earlier, that is log m raised to the power n. In that case, n will come in front of log m. Log e raised to the power x is x, and log e is equal to 1. Now, here in this part, we will apply differentiation. So here you can see that there are two things in product. First thing is gx, and the second thing is log fx. Two functions in product. In that case, we have to apply principle of method of the differentiation of two product case. Now I will take a practical example of it. We have to find dy by dx. The function is y is equal to x raised to the power x. X is not a number. That means we have to apply log. So we will write taking log on both sides of the equation. Y is equal to x raised to the power x. That is log y is equal to log x raised to the power x. As it was told to you that it is by the property of the log which is written in the red on the right side of your screen, that is log m raised to the power n. N will come in front of log m. So here in this case, it will become log y equal to x log x. Now we will differentiate. I told you that if it is if we are differentiating y, it will become dy by dx. But this is having log y. So what will we do? Derivative of log x is 1 by x. Derivative of log y will be 1 by y into dy by dx. You have to keep that thing in mind. And on the right hand side, we have two things in product. First one is x, second one is log x. So that means we have to apply UV method. In that case, x will be written as it is. We will be differentiating log x plus log x into differentiation of x. When we will be differentiating log y, we will get 1 by y by dx is equal to x into derivative of log x is 1 by x plus log x into derivative of x is 1. So what we will get? 1 by y, dy by dx is equal to 1 plus log x. We want our answer in dy by dx. So what we will be doing, we will be shifting this y on the right hand side. This will become y into 1 plus log x. Now, from the top, we can replace y by x raised to the power x. Therefore, our answer will be dy by dx is equal to x raised to the power x into 1 plus log x. This is the method where powers cannot be reduced or powers are not numbers. Second case is x raised to the power y is equal to y raised to the power x. We have to differentiate. So we will straight away write taking log on both sides. It will become log x raised to the power y equal to log y raised to the power x. We will bring y in front of log x for the left hand side, and for the right hand side we will bring x in front of log y. Now you can see that this is a form of implicit function. There are two functions to be in multiplication form in the left hand side and two functions in the multiplication form in the right side. That means we will be applying product rule on the left hand side as well as on the right hand side. We will start with y d by dx log x plus log x derivative of y is dy by dx is equal to first function x, first function is x, derivative of log y plus log y derivative of x. Coming down, derivative of log x is 1 by x. So it will become y into 1 by x plus log x dy by dx equal to, now see carefully, it is log y. You are finding out derivative of log y. It will be 1 by y times dy by dx plus log y. Now, in the next step, what we will be doing? We will be bringing all dy by dx in the left hand side. So we will have log x dy by dx minus x by y dy by dx is equal to all remaining part on the left hand side or the right hand side. So it will be log y minus y by x. Now we can take dy by dx common. We are left with log x minus x by y. And on the right hand side, we have log y minus y by x. What we will be doing, because we have Abdul Rahman, please mute yourself. So dy by dx will be equal to x log y minus y upon y log x minus x times y by x. This is the derivative. Next one, this is a composite function. Now the thing is that you can see that there are number function, and in one function you have power 10 and rest all are in multiple form and are linear. We have numerator as well as denominator. Something which is not so common. So straight away what will happen? Straight away when we have this type of uh, difficult problems, so we straight away apply log. So we will be applying log on both sides. The left hand side will become log y, and in the right hand side we will write log and the function. Now we will apply properties of log. You can see that in the numerator form there are three functions which are in multiplicative form. When we apply log in multiplicative functions, so it becomes log m plus log n. There are three multiples, so what we will be doing, individually we will be applying log and we will be putting up addition sign. So it will become log x plus 1 raised to the power 10 plus log x plus 5 plus log x plus 6 minus, because it is in the division So it will become minus and it will become log x plus 7 power 2. In the next step, we will bring this 10 in front of log x. So it will become log y equal to 10 log x plus 1 plus log x plus 5 plus log x plus 6 minus, we will bring 2 in front of log x plus 7. It will become minus 2 log x plus 7. Now this is a linear form. In the linear form, now we will straight away apply. So in the left hand side, log y is 1 by y dy by dx is equal to 10 log x plus 1 will be 10 by x plus 1 plus log of a derivative of log x plus 5 will be 1 upon x plus 5. Derivative of log x plus 6 will be 1 upon x plus 6 minus 2 times 2 upon x plus 7. Now what we will do, we will take up the LCM and we will write it. Now, there is no need of solving this question further. So we will straight away, we can leave in this form and we will replace this y over here. Y is this question. So this will come over here. So your answer will be this one. Fine. Now you can see over here, I'm just discussing about this is the most difficult part of this differentiation where students normally get confused. Now here you can see the power is in the form of 1 by x. It is not a number, it is a function. So straight away we will apply log. Taking log on both sides, log y equal to log 3x square plus 5 raised to the power 1 by x. Anything which is in the power will come in front. So it will become log y is equal to 1 by x times log 3x square plus 5. Here you see it is in the division form. Log 3x square plus 5 is in the numerator and in the denominator we have 1 by x. Now the thing is that we can do one thing. We have 1 by x as the first function and log 3x square plus 5 as the second function. We can keep it in differentiation form, our product form. So we can apply product rule. On the left hand side, it will be 1 by y dy by dx equal to 1 by x, the first function, derivative of the second function, that is log 3x square plus 5, plus second function as it is, that is log 3x square plus 5, into derivative of the first function, that is 1 by x. Now we will be simplifying it. 1 by y dy by dx is equal to 1 by x into. Now you have to be careful over here how to apply derivative of this. This will be 6x plus log 3x square plus 5. Derivative of 1 by x is minus x is to the power minus 2. Now what we will be doing, we will just simplifying it and we will get 1 by y dy by dx equal to 6 minus log 3x square plus 5 by x square. We can replace this y with this. So straight away we will be replacing over here. So we will get dy by dx is equal to 3x square plus 5 raised to the power 1 by x times 6 minus log 3x square plus 5 by x square. This is our differentiation by logarithmic methods. Now we move on to derivative of inverse function. Here what will happen, normally what we do, we find dy by dx. But in this case, you will be asked to find dx by dy. So dx by dy can be written as 1 upon dy by dx. But we have to be careful in that. If your function is y is equal to fx, and we want to solve this equation for x in terms of y, so we will write this function as x is equal to g of y. The g of y is called the inverse of the function fx. If y is equal to fx is differentiable function as such that f dash x is not equal to 0, then your x is equal to gy is also differentiable at the corresponding value of y, and dx by dy is equal to 1 upon dy by dx. Simply, in other words, we can say that if in any question you are being asked to calculate dx by dy, so don't get confused. Straight away find dy by dx and just reciprocate. I will show you how. Here it is. You are being asked to calculate dx by dy. Your function is y is equal to 3x plus 2 divided by x plus 1. You can see that this is in the form of numerator and denominator. So we have to apply u by v method, that is division method. So in that case, dy by dx will be equal to square of the denominator. This denominator will come in the numerator and we will differentiate 3x plus 2. Differentiation of 3x plus 2 is 3 minus second function as it is 3x plus 2 differentiation of x plus 1. Derivative of x is 1 and derivative is constant is 0. So we are left with 1. We will just open it up and we will get dy by dx is equal to 1 upon x plus 1 whole square. As I told you, and in the question you have been asked to calculate dx by dy, and you have calculated dy by dx. So I will be just reciprocating it. So it will be x plus 1 whole square. This is the answer. Now, how to differentiate parametric function? Till now, we have differentiated a single function. Now, here we are going to get two functions. Suppose we get x is equal to ft and y is equal to gt. Then we can say that both x and y are related to t. And in this case, we apply chain rule. Now, how to solve it? Your function is x is equal to ft and the second function is y is equal to gt. When you are going to differentiate x with in terms of t, so you are going to get dx by dt, and when you are going to differentiate y in terms of t, you are going to get dy by dt. But you are being asked to calculate dy by dx. How you will solve it? See to it, dy by dx can be written as dy by dt upon dx by dt. But you have to be careful that dx by dt is not equal to 0. If in any case dx by dt is 0, so your derivative will be infinity, because anything divided by 0 is infinity. We'll see how this is calculated. You are being asked to calculate dy by dx. Your first function is y is equal to t power 3 and the second function is x is equal to t power 2. So in first case, we will be applying dy by dt. Dy by dt will be 3t square and dx by dt will be 2t. You are being asked to calculate dy by dx. So dy by dx will be dy by dt divided by dx by dt. So you will be getting 3t square by 2t. That means your answer will be 3 by 2 times t. This is how parametric functions are solved. This is another case where you are going to get first function in the form of u by v and second function in the form of, that is a combination of two things. You can see to it y is equal to 2t cubed plus 4 power t. We will start with x. X is equal to 1 minus t upon 1 plus t. So we will be applying the u by v method. So dx by dt will be 1 plus t ka whole square. In the numerator, it will be 1 by t into derivative of 1 minus t. The derivative of 1 minus t will be minus 1. Minus 1 minus t times derivative of 1 plus t. Derivative of 1 plus t will be 1. So you are left with minus 2 divided by 1 plus t whole square. Now move to y part. Y is equal to dy by dt is 6t square plus 4t log 4, because derivative of x raised to the power a, a raised to the power t is a raised to the power t log a. So here for 4 raised to the power t, we are going to get 4 raised to the power t times log 4. We have to calculate dy by dt. So we will be writing dy by dt is equal to dy by dt upon dx by dt. Simply transforming the values, so you will get dy by dx is equal to 6t square plus 4t log 4 times 1 plus t whole square divided by minus t. This is another example how parametric problems are solved. Now we move to unit 8. Here you have to be careful because we will be finding first derivative, second derivative, and third derivative. Now the thing is that how to represent first derivative, you know it, dy by dx. Second derivative is d square y upon dx square. Or in the simpler form, if your function is with fx, its first derivative will be f dash x. Its second derivative will be represented by f double dash x. And f double dash x is for the third derivative. So I will show you. You can see over here, the function is fx equal to 5x power 4 plus 6x cube plus 2x plus 1. When we are going to find the first derivative, so it will be 20x cube plus 18x square plus 2. Again differentiating. Second derivative is f double dash x is equal to 60x square plus 36x. Now, third derivative f triple dash of x is equal to 120x plus 36. Now the thing is that why this has been taught to you. Now, here, moving further, we will be having its application. Now the thing is that how, what, why this second derivative and third derivative is being taught to you. That means what is its interpretation. The first derivative of the function y is equal to fx is dy by dx, which means that the rate of change of y due to change in x. Or we can say that it gives a slope of the curve at a point. Now, if your first derivative is positive, listen to it very carefully because it will be asked in your assignment as well as in your paper. Its application. Now, if first derivative is greater than 0, it implies that y increases for some increase in the value of x. If dy by dx is equal to 0, it implies that y does not change for a small increase in the value of x. And if your first derivative is less than 0, that means y decreases for the small increase in the value of x. Now, what is the perception of second derivative? The second derivative is d square y upon dx square. It gives the rate of change of dy by dx. Then, if second derivative, listen to it very carefully, if second derivative is greater than 0, the function has increasing slope. And if second derivative is less than 0, it has decreasing slope. One is going up and the other one is going down. Now, how to apply this and how to write the answers. Broadly speaking, a function's fx is increasing when y is increasing as x gets larger. That is looking left to right. And fx is decreasing when y decreases as x gets greater. Such functions are of interest to us for determining the rate of change of variable. For example, we would be interested to know the speed of a car or rate of growing and declining population of the country. That means by finding out the derivative, we can interpret whether the speed is increasing or the population is coming down. We will see to it how it works. For increasing function, a function is fx, y is equal to fx. It is said to be increasing for the interval a comma b if y increases as x increases. As s increases in ab, ab is your two values. If x1 and x2 belongs to ab and x2 is greater than x or equal to x1, then function at x2 will be greater than or equal to function at x1. We'll see to it how. A function is said to be increasing in the order derivative is greater than 0. That means f dash x is greater than 0 for all values of x in the interval of a b. If first derivative is greater than 0, then the curve increases from left to right. You can see that it is moving from this to this part. That means it is an increasing curve. Similarly, if it is coming down, you see over here, same thing, everything is same only, but the values are different. So this curve is coming down for the interval a comma b because fx2 is less than equal to fx1. Now, how to apply it in a problem? Suppose we have to find the interval in which the function fx is increasing and decreasing. Straight away, what we will be doing? We will be finding out the derivative. So your function is fx is equal to 2x cubed plus 9x squared plus 12x minus 1. We will have to find derivative of it, which will be dy by dx, which is equal to f dash x is equal to 6x squared plus 18x plus 12. What we will be doing? We have to simplify it, or we can simplify it. We will be taking 6 common. So we are left with 6 times x squared plus 3x plus 2. Now we will be factorizing this because the maximum power is 2. So you are going to get 2 factors. When you are going to split its middle term and solving, so you will be getting 6 times x plus 1 into x plus 2. This is the first step. That means you have to find the derivative. Now, for second step, if it is increasing, f dash x should be greater than 0. What is your f dash x? It is 6 comma 6 into x plus 1 into x plus 2. If you are going to keep any value of x greater than minus 2, what will happen? 6 will remain 6. The sign in the center value over here. See, minus 2 plus 1 will be a negative number, and minus 2 plus 2 will be 0. You can leave it. Suppose you keep minus 1. Again, 0. If you keep x is equal to 0, so it will be 6 into 1 into 2. That will be greater than 0. In that case, what will happen? It is increased. And if you take x greater than equal to greater than minus 1, so in the first bracket you are going to get plus sign always, and the second again positive. That means a positive number will be there. So it is again increasing. Or we can say that the function is increasing when x belongs to minus infinity to minus 2, union minus 1 to plus infinity. If the function is increasing from minus infinity to minus 2 and again increasing from minus 1 to infinity, that means it is a case that it will be decreasing between minus 2 and minus 1. Now we will see how it will be decreasing. You have your second derivative of x as 6 times x plus 1 into x plus 2. Now keep any value between minus 2 and minus 1. Suppose you keep to 1.5. So in the first case, it will be negative 1.5, it will be negative number. And in the right side, it will be a positive number. That means when a negative number is being multiplied by a positive number, you are going to get a negative number which is less than 0. That means your derivative is less than 0 between -2 and -2. So how its answer will be written for decreasing function? It is -2 and -1. It is increasing in x belongs to minus infinity to -2 union -1 comma infinity, and it is decreasing for x belongs to -2 comma minus. Now we will take another problem which is related to your business mathematics. A revenue function of the firm is given by r is equal to 8 lakhs plus x minus 300 raised to the power 2. You have to determine the value of x for which total revenue function is increasing and decreasing. If you are being asked to find the value of x of the total revenue function when it is increasing and decreasing, so straight away what will you do? You will find out the derivative of the revenue function. That will be derivative of constant. That means derivative of 8 lakhs will be 0, and this is a function in the form of x raised to the power n. In that case, when the derivative is being calculated, so 2 will come in front of x minus 300 and the derivative of x will be 1. That means the derivative of the function, revenue function, will be 2 times x minus 300. Straight away what we are going to do, we have to find out the value of x is equal to or you can do one thing, or you can find out straight away first derivative greater than 0. So for first derivative greater than 0, you have to take all the values greater than 300. Correct? That means the function will be increasing for any value greater than 300, and your value and for decreasing part, any value which starts from 0, no production, no output, x is equal to 0, it will be a negative function. That is a stationary value. That means you can say that minimum you have to produce quantity more than 300. Then comes maxima and minima. In maxima and minima, we have to find out second derivative. Till now we have not, for increasing and decreasing, we are not we don't require anything to calculate second derivative. But for calculating maxima and minima, we have to calculate second derivative. Maxima or minima of a function is the largest or the smallest value of the function, defined either within a given range or on the entire domain of the function. Maximum means upper bound or the largest possible value. The absolute maximum of a function is the largest number contained in the range of the function. Now, what are the different steps? First derivative test for local extreme values. What we will be doing? We will be finding f dash x. Then we will be putting this f dash x equal to 0. That means in mathematical terms, we will be solving this, and these values of x will be the critical values. Now, we have to see, as what we have done in increasing and decreasing, we have to see if the sign of first derivative f dash x changes from positive to negative as x increases through a, then the function attains a local maxima at x is equal to a. And if f dash x changes from negative to positive as s increases through a, then the function attains a local minima at x is equal to a. Fourthly, if f dash x does not change its sign as s increases a, then there is no local extreme at x is equal to a. Such point is known as point of inflection. Now, in short, a function fx is said to be maximum if f dash x is equal to 0 and f double dash x is less than 0 at a critical value of x is equal to a. Its vice versa is minimum if f dash x is equal to 0 and second derivative is greater than 0 at the critical value x is equal to 0. Now, if second derivative is equal to 0 and third derivative is not 0, that is the point of inflection. So, in short, you can see that for maximum, we have to calculate dy by dx, and for second derivative, you have to calculate the second derivative. And for minimum, and it has to be less than 0. Second derivative has to be less than 0. And if the second derivative is greater than 0, it is local minimum. Now, mathematically, what is happening, you can see over here that green line, which is parallel to x-axis at two places, shows the slope. That is dy by dx. At that point, dy by dx is 0 in all the two cases. And on the left of your screen, you can see that dy by dx is greater than 0. That means it is sloping upwards. And at C, dy by dx is less than 0. And again at E, dy by dx is greater than 0. And again at F, dy by dx is less than 0. That means wherever it is greater than 0, it is increasing. Wherever it is 0, it is moving. And wherever it is less than 0, it is coming down. This is the graphical representation how maxima and minima of a function takes place. This has been discussed already in the graph. Now, what are the steps of finding maxima and minima using second order derivative? First of all, you have to calculate f dash x. Put f dash x is equal to 0. You are going to get the value of x. It can be one value or two values. You have to calculate second derivative. If your second derivative is greater than 0, it is a point of local minima. And if your second derivative at that point is less than 0, that is local maximum. And if your second derivative is 0, then you have to find out the third derivative. Third derivative can be 0 or it can be not. Information regarding maximization and minimization of a function can only be gathered at an even ordered derivative, whereas information regarding the point of inflection can be collected at an odd order derivative. Now see how they are represented. First order, dy by dx. Second order, f double dash x or d square y upon dx square. Third is f triple dash or d cube by y upon dy dx cube. Fourth is f power 4, d4 y upon dx4 and so on. And for the nth it is d raised to the power n y upon dx raised to the power n. Now we have already calculated the third derivative. Your function is fx is equal to 3x5 minus 2x cubed plus 14. You have to calculate the first derivative. First derivative is 15x power 4 minus 6x squared. Your second derivative is represented by f double dash x, which is 60x cubed minus 12x. The third derivative is f triple dash x is equal to 180 x power 2 minus 12. Now we will find out the point of local maxima and local minima for the function fx is equal to 2x cubed minus 15x squared minus 36x plus 60. First of all, what is the method? We will be finding out its derivative. Its derivative is 6x squared minus 30x plus 36. We can take 6 common from it. So we are left with x squared minus 5x plus 6. This is a quadratic function, so it can be still broken down or it can be factorized by breaking up the middle term. So you are going to get 6 times x minus 2 into x minus 2. First step is over. Now we have to put f dash x is equal to 0. 6 cannot be 0. That means x minus 2 will be 0 or x minus 3 will be 0. That means either x is equal to 2 or x is equal to 3. Now, if we take up any value which is greater than a value of x less than 2, in both the brackets it will be a negative sign. When the negative sign are multiplied, you will get a positive sign. That means your first derivative will be greater than 0 for any value of x less than 2. Between 2 and 3, in first bracket you are going to get plus sign, and then the second derivative you are going to get a second negative sign. That means it will always be a negative number. And for x greater than 3, you will get a positive number. It will be greater than 0. That means you can see that f dash x is changing its sign from plus to minus as s increases through 2. X is equal to 2 is the point of local maximum. Similarly, f dash x changes its sign from negative to positive as s increases through 3. Therefore, x is equal to 3 is a point of local minimum. Now, this is a cubic function. Fx, you are being asked to find the point of maxima and minima. Fx is equal to x cubed minus 3x squared minus 9x plus 6. First derivative will be 3x squared minus 6x plus minus 9. Take 3 common. You are left with x squared minus 2x minus 3. Since this is a quadratic function, split its middle term. So it will be 3 times x plus 1 into x minus 2. Your second step is put f dash x is equal to 0. By putting f dash x is equal to 0, you are going to get two values of x. X is equal to minus 1 and x is equal to 3. Find out the second derivative. Second derivative of which f dash x is equal to 3x squared minus 6x minus 9. So your second derivative will be 6x minus 6. Straight away put up the value of x is equal to minus 1. When you are putting up the value of x is equal to minus 1 in the second derivative, you are getting a sign of minus 12. And your second derivative at x is equal to minus 1. That means you are getting second derivative as negative. That will be a point of local. Yeah, please ask your question. What is your question? Am I audible to you? What is your question? What do you want to ask? Am I audible to you? Can you hear
Uh,
me?
yes, I can hear you, sir. So, what I'm saying is
What?
that
What?
I'm kindly asking if you can be a bit slow. You are too fast. I'm not getting most of it, and
Okay.
I'm kindly asking if it's going to be possible for you to be solving while explaining. Maybe you solve one example because most of the calculations I'm failing to get them.
Okay. That's good. You have to tell me your problem because I'm just doing the calculation. Uh, it has been done, but I will make you understand in a simpler way. So I will be keeping this problem with it. Is the slide visible to you?
Yes, it's visible, sir. So, what I'm saying is that is it possible for you to solve at least one example while you are explaining? Because most of it, I'm not getting it, and you are a bit fast, like to my own side.
Okay. The problem is in front of you. Fx is equal to x cube minus 3x squared minus 6x plus 6. How to calculate its derivative? It is of the standard form x raised to the power n, and its derivative is n x raised to the power n minus 1. Here you have x cube. So 3 will come in front of it, 3x, and 1 power will be reduced. So 3 minus 1 is 2. So it will be 3x squared. Similarly, for 3x squared, you will be multiplying 3 into 2, that is 6. And for x, you will be reducing 1 power. For minus 9x, derivative of x is 1. So you will be left with minus 9. And derivative of 60, that is a constant, it is 0. There is no need of writing it. So that means f dash x is 3x squared minus 6x minus 9. In the next step, you have to take 3 common. So when you are going to take 3 common, you are left with what? X squared minus 2x minus 3. Now, this is a quadratic function. We can split its middle term. So after splitting the middle term, you are going to get 3 times of x plus 1, x minus 3. This is the basic first step for finding out the local maxima and local minima for a function. There are 3 steps to be performed. First one is derivative of the function. Second step is put this derivative of x equal to 0. Third step, you have to study the second derivative at these points. Going back to the problem, we will put f dash x is equal to 0. So when we are going to put f dash x, your f dash x is 3 times of x plus 1 into x minus 3. X will be equal to minus 1 and x will be equal to 3. That means you are going to have two values of x. X is equal to minus 1 and x is equal to 3. Now, the next step is to study the second derivative at these points. So straight away what we will be doing? We will be differentiating this function, this marked with red. I will be differentiating this function. This will be f double dash of x. 2 into 3 is 6, 6x minus 6. This is your second derivative. Now, as I told you, we will be studying the nature of second derivative. So we have two problems, two values of x, minus 1 and 3. So simultaneously, we will be putting these values. Second derivative at minus 1 will be 6 into minus 1 minus 6. that will be minus 12. Second derivative at minus 1 is negative. That means that is a point of local maximum. Similarly, we will be studying at x is equal to 3. That means we will be studying second derivative at x is equal to 3. So here in this case, we are going to get 18 minus 6, that is plus 12. Or we can say that x is equal to 3 is a point of local minimum. This is how we find the point of local maxima and minima for a function. I am repeating it what I did. Whatsoever the problem is given to you, no doubt it will be an algebraic problem. Differentiate it, equate this different, whatever you are going to get with 0. Mathematically, it is f dash x is equal to 0. So you are going to get either 2, 1, 2, or 3 values of x, depending upon the nature of the function. Then we have two things. We have completed two things. We have calculated the first derivative. We have calculated the value of x. Now, next step is to find out the second derivative and to study the nature of second derivative at these values of x, what you have calculated. If the second derivative is negative, that is a point of local maximum. And if your second derivative is positive, it is a point of local minimum. This is what we had been discussing. Now, moving further, application of derivatives. Application of derivatives to elasticity of demand as well as to supply, cost and revenue function, profit maximization, and the importance of derivatives in maxima, minima problem. Whatever I told you today, I will be doing it to you in application of businesses. First of all, we will start with demand function and supply function. In microeconomics analysis, it is postulated that demand and supply are functions of price. While the quantity demanded is related to price inversely, in case of supply, it has a direct relationship with the price. It's very well understood. It's nothing to be that much applicative. If for any commodity the price is going to decrease, your purchasing power will increase. And if the price increases, your purchasing power will be decreasing. That means it has inverse effect. In such a proposition, we have a downward sloping demand curve and upward sloping supply curve. For the sake of its simplicity, we often assume the demand curve and supply curve for a goods or services to be a linear line. Although other nonlinear types are also considered. The consequent slopes of demand and supply curves are respectively negative and positive. We know that a linear equation is in the form of y is equal to mx plus c, where m is the slope of the line and c is the y-intercept. Now we have a model, a demand function as q is equal to minus ap plus b. Straight away you can see that it has having minus sign in a part. That means it has an inverse. Or we can say that inverse demand function is P is equal to minus AQ plus P, where P and Q represents price and quantity respectively. We keep the price on the horizontal axis. X-axis on x-axis we keep the price. and the quantity on the vertical axis, that means at y-axis. In the event of presenting inverse demand function, we consider quantity in horizontal axis and price in the vertical axis. Now, studying the nature of the slope. In case of the equation demand curve Q is equal to minus AP plus B, when we differentiate it in terms with respect to Q, we are differentiating Q with respect to P. That means it will be dQ by dP, which will be equal to minus A. That means the slope is minus A, and this gives the rate of change in quantity demanded in response to the change in the price. This is what we know. If the price increases, demand. If the demand increases, the price increases. Something we have to now we are studying something in mathematical terms. The downward sloping demand curve is represented by a negative slope. That means it will be coming down. Reason for this further could be threefold. First one, substitution effect. Consumers will substitute other goods to buy more or less according as price falls or rises. Understood? Income effect. Rise or fall in real income as price falls or rise. The third one is law of diminishing utility. That is, at a lower price, consumers are willing to consume more as they compare the price with the satisfaction that is derived from the consumption of that good. Now, study the slope of supply curve. Suppose we consider an equation Q is equal to Cp plus D. That means here what we will be doing, we will be differentiating Q with respect to P. So when we will be differentiating Q with respect to P, it will be dQ upon dP, which will be equal to C. Here you see that it is having a positive sign, which indicates a positive relationship between quantity supplied and price. What are the reasons for this? That means it could be for the profit motive. With rise in prices following an increase in demand, it becomes more profitable for businesses to increase their output. Second one is production and cost. Firms' production cost tends to rise as output expands. Consequently, a higher price is needed to cover these extra costs of production. And third one is incentive for new entrants. Higher prices may create an incentive for the other businesses to enter into the market, leading to an increase in total supply. Now, next part is elasticity, demand, and supply function. Elasticity refers to the responsiveness of the dependent variable of a function to changes in the independent variable. It is measured in the terms of percentage. That means straight away we can say that percentage change in x is change in the variable x upon its original value. We can say that change in x is delta x. If x changes from x to x plus delta x, then its proportional change will be delta x by. If concerned with elasticity, then we can say that elasticity of y with respect to x, and we need to find the ratio of the percentage change in y to the percentage change in x. For that, elasticity of y with respect to x will be percentage change in y upon percentage change in x. If your elasticity is defined with a negative sign, while at others in absolute way. When an elasticity is negative and say greater than -1, it indicates that the percent increase in x corresponds to greater percentage decrease in y. That means we have a negative relation. In such a case, we would say that variable y is elastic with respect to variable x. If we have elasticity between -1 and 0, it indicates that percent increase in x corresponds to a smaller percentage decrease in y. So the variable y is inelastic with respect to variable x. If the elasticity is of -1, then a percent increase in x corresponds to an additional percent decrease in variable y. Price elasticity of demand. The most common use of elasticity in economics and business studies is price elasticity of demand, what we call it as E, and elasticity of demand with respect to price. Such a concept helps us to explore the responsiveness of the consumer demand for some product to change in the price of the product. If the price of a cup of coffee were to increase, the quantity sold will be inferior. You see just now how these values vary and how to make you understand what is the application of differentiation in your business environment. Now see, to see the point, suppose that in 2016, Nestle increased the price of coffee from rupees 4.95 to rupees 5. That means we can say that a mere increase of 0.05. Due to such a change, the demand for coffees dropped from 440 units per day to 438 units per day. That means what you can calculate. What is the percentage change in the price? That means the difference of the original price divided by the original price. The difference, as I told you, will be is 0.05, and when you are going to divide it, you are going to get 0.01, which is equivalent to 1%. That means percentage change in the demand is delta Q upon Q. Earlier it was 440 and now it is 438. So 438 minus 440 divided by 440, which becomes negative. Therefore, we can say that with 1% increase in the price, 0.45% decrease in the quantity demanded. That means the price elasticity of demand will be E is equal to delta Q upon delta P. Your delta Q is negative 0.0045 and your delta P is 0.01. When you are going to divide it, you are going to get negative 0.45. Now, what does this mean? This means that with 1% increase in price, it corresponds to 0.45% drop in demand for coffee. Or in other words, we can say that 1% drop in price corresponds to 0.45% increase in demand. This is the mathematical interpretation of the problem. The next part, taking into account the relationship between demand and price in a functional form. We can use derivative of the demand function to calculate the price elasticity of demand. Now, how to calculate it? If we write that the change in price is being from P to delta P and the corresponding change in demand as Q to delta Q, then the corresponding percentage change in price and demand will be delta P by P and delta Q by Q. By the definition of elasticity, it is represented by ED equal to percentage change in Q divided by percentage change in P. So we will be putting up the values delta Q upon Q divided by delta P upon P. By further replacing, we can say that ED is equal to P by Q into delta Q upon delta P. Now, if your demand function is Q is equal to FP, then the price elasticity ED will be P by Q into dQ upon dP, what you have done right now. Now the question arises, if we know price elasticity of the demand and we have to find its value at a particular point of P0 Q0, then how it will be represented? That means it will be PED equal to dQ upon dP into P naught upon Q naught. See, to find the point price elasticity of demand, the Q is 15,000 minus 50P. Given this demand curve, we need to find out price elasticity of demand at two different prices. First one is P is equal to 100 and the second one is P is equal to 10. What we will be doing, I will be differentiating this delta Q upon delta P. So I'm going to get minus 50. To find the quantity demanded at each price level, we consider the price quantity combination of 100 and 10,000. We have, or we can take 10 and 14,500. Now we have to calculate the point elasticity of demand yields. We know that it is delta Q upon delta P into P by Q. We will be putting up the values minus 50 times 100 divided by 10,000, and in the second case it will be minus 50 into 10 divided by 14,500. So we are going to get the value as minus 0.5 and minus 0.34. Or we can say that in both the cases, elasticity is negative in nature, which implies that a downing sloping demand relationship is there. Moreover, they are relatively more elastic. Then the next part is income elasticity of demand. The income elasticity of demand measures how effect of the change in the consumer's income on the demand for a specific product. It is defined as the ratio of proportionate change in quantity demanded due to proportional change in income, which is denoted by Y. There is a positive relationship between income and demand in case of normal goods. Hence, sign of income scarcity if demand is positive. That means now it will be EY equal to proportionate change in demand divided by proportionate change in income. So it will be dQ upon Q divided by Y upon delta Y because your income is related by Y. So here this will become Y upon Q into dQ upon delta Y. or a case of instantaneous change in time. Now we will see to it. If x is equal to 4y square, where x is quantity demanded of a good and y is the consumer's income, find the income elasticity of the demand. Pick up the problem. It is x is equal to 4y square. You will differentiate it. It will become 8y. So dx by dy is equal to 8y. Your formula is ey is equal to dx by dy into y by x. Y by x, it will be 8y into y upon 4y square, which is equal to 2. You can substitute, or you have to substitute this value over here. The higher the income elasticity of demand for a specific product, the more responsive it becomes to the change in consumers' income. Now we can measure the income elasticity of demand for different products by categorizing them into inferior goods and normal goods. Point elasticity of demand, ED is equal to dq upon dp into p by q. If ED is negative, the downward sloping demand of curve will be there. For inelastic demand, ED is less than 1. For unit elastic demand, ED is equal to 1. And for elastic demand, ED is greater than 1. Now, normal goods. If YED for a product can be elastic or inelastic based on its category, whether it is an inferior good or a normal good. When YED is more than 0, the product is income elastic. Normal goods have a positive YED. That is, when the consumer's income increases, the demand for these goods also increases. Second one is inferior goods. Inferior goods are the goods. So because they have superior alternative, such goods have a negative income elasticity. That is why it is less than 0. If the consumer's income increases, they demand less of these goods. Note, if sign of income elasticity of demand is negative, then the commodity is inferior. Then what is the correlation for elasticity of supply? Elasticity of supply is the ratio of proportionate change in supply to the proportionate change in price. So supply is Qs by Qs divided by delta P by Q. By transforming, it will be negative P by Qs into delta Qs upon delta P. Now see, suppose we have a supply function x is equal to 5 plus p square. We have to find the elasticity of supply at p is equal to 2. We have this function x is equal to 5 plus 2p square. We will be differentiating it with respect to p. So it will be dx by dp is equal to 4p. Going back to the elasticity of supply, es is equal to p upon x into delta x upon delta p. Substituting the value, you are going to get 4p square upon 5 plus 2p square. Now you have to calculate the value at p is equal to 2. So straight away, substitute the value of p equal to 2 in this function. It will be 4 into 4 divided by 5 plus 8. It will be 16 by 30. We have to substitute the value over here. Then comes your cross elasticity of demand. Cross elasticity of demand is the responsiveness of demand for a product in relation to the change in the price of another related mark word related product. Note that unrelated products have zero elasticity of demand. For example, an increase in the price of black gram will have no effect on the demand of ice because we don't that does not have any relation. We can measure the cross elasticity of demand by dividing the percentage of change in the demand for one product by the percentage of the demand in second. That means cross elasticity of demand is equal to percentage of change in the demand for product A to the percentage of change for the price of product B. That means this is a relation between demand and price. It is useful to note that the cross elasticity of demand depends on whether the related product is a substitute or a complement. Now, what are substitute and complementary products? Cross elasticity measures the responsiveness of demand in relation to related products, and also these related products can be either substitutes or complementary products. As far as we talk about substitute products, an increase in the price of one will lead to an increase in the demand of the competing product. For example, an increase in the price of petrol will force consumers to go for diesel, and increase in the demand for diesel will be there. Thus, we can say that the cross price elasticity value for two substitute goods is always positive. Complementary products. In case of complementary goods, demand for two or more goods move together. For example, the demand for coffee beans and the coffee paper filers. If the price of coffee increases, then the demand for the flowers would reduce because the demand is related for coffee. The cross elasticity of demand for two complementary products is always negative. Then what is average and marginal cost? Total cost is what? We know that total cost is the sum of variable cost and fixed cost. Fixed cost, that is the cost remains constant for all levels of output. That is independent of the quantity produced. For example, cost of machinery or rent of the factory building falls in this category. Second one is variable cost. The variable cost is the level of output. It varies with the level of output. For example, cost of raw material forms a part of the variable cost. Average cost, that is total cost divided by total number of units produced. That is TC by Q. Marginal cost. Marginal cost is the rate of change in total cost. That is DTC upon DT. What is the relationship between average costs and marginal costs? You will see a diagram over here. Here you see there are three conditions. If derivative of AC with respect to x is less than 0, in that case, MC will be less than AC. That means marginal cost will be less than average cost. Moving further, DC upon DAC upon DX. Here we get MC equal to AC. And on the extreme right side, you can see that is if the derivative of AC is greater than 0. In that case, marginal cost will be greater than average cost. It will be a sloping downward. You can see in the graph on the x-axis we have output, and on the y-axis for one part we have average cost and the second part is marginal cost. When we talk in terms of output and average cost, you can see the graph is U. And if we talk in terms of marginal cost and output, it is again a U, but it is somewhat sweeper. So this is the graphical relationship between how the relation between two commodities, that is the marginal cost and the average cost, is evaluated. Now see, total cost is TC is equal to FC plus VC. Total revenue is the product of price into quantity. Profit is total revenue minus total cost. Break even is the point where total revenue is equal to total cost. And profit maximization is when MR is equal to MC. Now the question is, what is MR? MR is differentiating total revenue by total quantity. And your marginal cost is derivative of total cost The problem is the total cost function is Cx is equal to 0.005 x cube minus 0.002 x square minus 30x plus 5,000, where x is the output. First of all, you have to calculate fixed cost, variable cost, average cost, average variable cost, marginal cost. Marginal cost when 50 units are produced, and you have to interpret the result. Next one is actual cost of producing 51st unit. Rate of change in marginal cost with respect to x and marginal average cost. What we will be doing? Straight away, cost function is given to us. We have to find out the value of fixed cost. For finding out the value of fixed cost in the original function, put x is equal to 0. As soon as you are going to put x is equal to 0, that means output is 0. Your FC will be 5,000. As you know that total cost function is addition of fixed cost plus variable. Then comes your variable cost. Variable cost is PC minus FC. That means it will be a function of algebraic in nature. It won't be having any numerical number with it, independent number. That is your variable. Now you are find out to average cost. Average cost is total cost divided by x. Your total cost is your original function divided by x. When you will be dividing each function by x, you are going to get 0.005 x square minus 0.002 x minus 30 plus 5,000 by x. Next is average variable cost. Average variable cost is variable cost divided by x. That means you are going to divide this variable cost by x. You will be getting 0.005 x square minus 0.002 x minus 30. Here it is. Then comes your marginal cost. Marginal cost is derivative of total cost. Where is the total cost? This is the total cost. Find out its derivative. That means you have to differentiate this term. It will be 0.15 x square minus 0.004 x minus 30. Here it is. Then comes, you have to calculate marginal cost when x is equal to 50. Straight away, write down, replace x by 50, and you are going to get value as 7.3. What is the interpretation from it? It means if production increases by 1 unit from 50th unit to 51st unit, then the total cost increase is increased by rupees 7.3 approximately. Then you have to calculate. Seventh part was actual cost of producing 51st unit. So first you have to calculate the cost of 51 unit in the original function. Replace x by 51. So you will get 4128.05, and C50 will be 4120. What is the difference between it? Because 50 units are being produced. You are being asked to calculate the amount required, additional amount required to produce 51st unit. So you will be subtracting this. So this will come out to be 8.05 rupees. Then comes, what is the rate of change in marginal cost? So that means if you are being asked to calculate the rate of change of marginal cost, then differentiate marginal cost by dx. You will get 0.03x minus 0.004. Then what is the marginal average cost? Marginal average cost means differentiating average cost with respect to x. On differentiating, you will get 0.05x minus 0.002 minus 30 minus 5000 divided by x. Now this is a problem which is related to the concept. We have to prove that the slope of average cost curve is 1 upon x times mc minus ac, where your total cost is ax cubed plus bx squared plus cx plus. So what we will be doing? When we will be dividing total cost by x, we will be getting average cost. So we will be dividing total cost by x. In that case, you will be getting average cost as ax squared plus bx plus c plus d by x. What is the slope of average cost? That means you will be differentiating. So when you will be differentiating average cost, you will be getting 2ax plus b minus t upon x. Your marginal cost will be differentiation of ax cubed plus bx squared plus cx plus the basic function. Its derivative will be 3ax squared plus 2bx plus c. Now, this function is given to you. So you can replace marginal cost and average cost in the main term. It will be 1 by x, 3x squared plus 20bx plus c minus bx minus c minus d by x. So when you will be clubbing it, you will be getting 2ax plus b minus d by x, which is the slope of average. This was asked asked in the question. Revenue function. Simple. Number of units produced multiplied by the unit cost. A revenue function depicts the relation between revenue and the output. The revenue is the product of price and the output. The price of the product and its quantity sold. Needless to say, if the price of the goods increases, then the quantity of the sold decreases. So revenue may increase or decrease. If you have profit from the business, your revenue, no doubt that profit is due to the increase in revenue. And if it is in the loss, revenue will be falling down. Total revenue is TR equal to PQ, which is equal to price into function of quantity. If we want to have or to see the nature of relation between revenue and output, we have to examine the price elasticity of demand. Indeed, there is a very useful relationship between price elasticity and revenue change. Suppose the total revenue we express as TR is equal to PQ. There is a small change in the price, so that will be changed price will be P plus delta Q, P plus delta P, and similarly for the quantity Q plus delta Q. So that means your revenue will be product into cost plus delta P into Q plus delta Q. Now we will subtract TR from revenue. So we are going to get P delta Q plus Q delta P plus delta P delta Q. That means for a small change of delta P and delta Q, so we will be neglecting delta P upon delta P into delta Q because that will be a more smaller number. So your change in revenue will be P delta Q plus Q delta Q. Now, what is the rate of change of revenue per unit change in price? That means delta TR divided by delta P. You will be left with Q plus P delta Q upon delta P. It means revenue increases when the price increases if the elasticity of demand is less than 1 in absolute value. Similarly, revenue decreases with price increases if the elasticity of the demand is greater than 1 in absolute value. What is the relationship between average revenue, marginal revenue, and price elasticity of demand? TR upon Q or PQ upon Q or equal to P. Then comes marginal revenue. Marginal revenue is the change in total revenue resulting from the additional unit of output sold. That means DTR upon PQ. What is the relationship between elasticity and marginal revenue? We know that for small change of price it is delta P, and for small change in quantity it is delta P. Then what is the change in revenue? Delta TR upon delta P, which is equal to P plus Q delta Q upon delta P. Suppose we have to find the value of delta TR, which comes out to be Q delta P plus P delta Q. Now we will be dividing both sides by delta Q. Delta TR upon delta P is equal to Q delta P upon delta Q plus delta Q upon delta P. So we know that marginal revenue is equal to delta TR upon delta Q. What will we do? We can take this P common out because we are generating another relationship between MR and elasticity demand. MR is equal to P times of 1 plus Q delta P upon P delta Q. This is price elasticity. That means your relationship for the marginal revenue and elasticity will be MR equal to P times 1 plus 1 upon E. In interpreting such a result, we can say if elasticity of demand is minus 1, then marginal revenue is 0. That is, revenue does not change when we increase the output. If demand is elastic, the ED will be less than 1, which means 1 upon ED is always greater than 1. That means 1 minus 1 upon ED is negative. So revenue would decrease when we increase output. What is the relationship between elasticity, average revenue, and marginal revenue? We have just calculated marginal revenue is equal to P times of 1 minus 1 upon E. Multiplying both sides or multiplying P by that is Q by P, Q by Q on both sides. So you will be left with PQ upon Q into 1 minus 1 upon ED. On solving it, because the thing is that we are trying to calculate the elasticity demand in terms of average revenue and marginal revenue. On simplification, we can get AR upon AR minus MR. Now, how to maximize revenue? It is seen above that total revenue is influenced by price variation. In a market structure with monopoly, the producer controls the price. This is in contrast to pure competition, when price remains constant and it is independent from output. In that case, average revenue and marginal revenue are exactly the same. Now, if the demand function of the firm is given by P is equal to 5,000 minus 20 minus X, then you are being asked to calculate total revenue, marginal revenue, and we have to comment on the nature of the firm. Now see, P is average revenue, 5,000 minus 20x minus x squared. Total revenue is price into quantity sold. That means your P is 5,000 minus 20x minus x squared multiplied by unit produced, that is x. It will become 5,000x minus 20x squared minus x cubed. This is the total revenue. You have to calculate marginal revenue, differentiate it. You will get 5,000 minus 40x minus 3x squared. Here you can see that average revenue is not equal to marginal revenue. That means this is a case of monopolistic firm. How profit maximization is done. The profit maximizing firm chooses both input and output so as to maximize the difference between total revenue and total cost. The firm will adjust variables under its control such that it can no longer increase the profit further. Thus, the firm looks at each additional unit of input or output with respect to its effect input. Revenue function is price into quantity. Note that we are taking inverse demand function, PQ, which depicts price as a function of quantity for getting the revenue. As we will see below, it helps to calculate MR quickly, which is required for getting the profit maximizing condition for firms regardless of market structure. Now see how things are made up, understandable in mathematics. Profit function is the function of total revenue and total cost, and it can be expressed as pi cube is equal to PR cube minus TC. Total revenues price into quantity. That means you can say that pi is equal to pi cube into cube minus c. To maximize it, to maximize the profit, we have to differentiate it. When we will be differentiating it, d pi upon dq, that will be equal to dr upon dq minus dc upon dt, and we will be substitute equating it to 0. That means your dr upon dq will be equal to dc upon dt, which is a case of marginal revenue is equal to marginal cost. Such an equally specific the first order condition, and we must add the second order condition of profit maximization. So what we will be doing, we will be differentiating d pi upon dq. For second derivative, we are going to get d square pi upon dq square less than 0. Now see, by taking up a problem. A stereo manufacturer determines that in order to sell X units of new stereo, the price per unit in rupees must be Px is equal to 1000 minus X. The manufacturer also determines that the total cost of producing X units is given by Cx is equal to 3000 plus 20X. Now, what is to be calculated? Total revenue, total profit, how many units must the manufacturer produce and sell in order to maximize profit? What is the maximum profit? What price per unit must be charged in order to make the profit maximum? What you are given? You are given the cost function and you are given the price. Let's start with revenue. Revenue is what? Quantity into price. Your revenue function will be X into P. Your what is Rx? X into 1000 minus X, which comes out to be 1000X minus X squared. Profit is total revenue minus total cost. Total revenue is 1000X minus X squared minus 3000 plus 20X. On solving, you will get Px is equal to minus X squared plus 980X minus 3000. Differentiate. You will get 2X plus 90, 980 equal to 0. On equating it to 0, you will get X is equal to 490. That means since there is only one critical value, we can use the second derivative to determine whether or not it yields a maximum or minimum. You will be differentiating minus 2x plus 980. On differentiating it second time, that will be p double dash x will be equal to minus 2, which is a negative value. That means at 490, it will yield maximum. Thus, the profit is maximized when the plant produces 490 units and sell them. Maximum profit is given by profit function at 490. You will put up the value of 490 in the profit function. That means P490 will be equal to 2,37,100. Thus, the studio manufacturer makes a maximum profit of 2,37,100 when he produces 490 units and sells them. What is the price per unit to achieve the maximum profit? That is 1000 minus 490, which is equal to 510. Now we talk about unit 10, which is related to interest rates. Now the thing is that where this is applied, interest rates have different applications. They are applied in banks, they are applied in depreciation, they are applied in appreciation, and they are calculated monthly, quarterly, semi-annually, and annually. Depending upon the problem, The calculation is money can be lent or borrowed from one entity to another. The price to be paid for the use of a certain amount of money for a certain period of time is known as interest. It is considered as an expense to the borrower and income for the lender. It's very simple to understand. If I borrow $100 from you and I request you that please provide me $100, you will say, one of you will say, okay, sir, we will lend you $100, but for how much period you need? I say I need it for 3 months. You said, okay, sir, just provide me, I will provide you $100, but after 3 months, you have to provide me $105. Some calculation might have been calculated by you. That $5 is the interest what you are getting by lending me $100. The money which is borrowed or lent is the principal. In our case, principal amount was $100, amount was $105, period was 3 months, rate of interest can be calculated later on. The idea of interest is based on the time value of the money, the period for it is borrowed. It means that the money available at present point of time is worth more than the same amount of money at future point of the time. Keep that thing in mind. Interest is actually the amount charged for borrowing of money to compensate the lender for the lost opportunity cost of not having the money and also for various risks of lending money as a default risk. Simple interest. Simple interest is the interest calculated on the original amount borrowed. Thus, for the entire period of the computation, interest is calculated on the principal. Rates of interest are usually expressed as percentage. Your simple interest is principal into rate into time. Your amount is principal plus interest. That means calculating it, the amount is principal plus interest, so interest is P into R into T. When you will be adding up, take out P common and you will be left with 1 plus R. Amount is the total amount due at the end of the period, not at the beginning of the period. Now, if you buy a new car, Ramesh borrowed rupees 5 lakhs at 8% annual, simple interest for 3 years. How much interest he will pay? Simple. Your principal is 5 lakhs. Rate of interest is 8%. 8% means 8 by 100. Time is 3 years. You are being asked to calculate interest. Interest is equal to P into R into T. After putting up the value, you get interest as 1,20,300. That means the total borrowed amount was 5 lakhs. Amount paid back at a period of 3 years was 1 lakh 12 was 5 lakhs plus 1 lakh 20,000. That means total amount paid after 3 years was 6 lakhs 20,000. Its interest was 1 lakh 20,000. Now, Himanshi lends rupees 45,000 to Rama. Find the time required for this amount to yield 9,900 at simple interest at 11%. Here in this case, the time is not. We have interest, we have principal, we have rate, but time is not. So we will be equating in terms of time, which will be equal to interest upon P into R. We have all the values with us. We have interest of 9,900. We have the principal of 45,000 and we have a rate of 11%, that is 0.11. After calculating, we get a period of 2 years. In this case, we can say that this amount was lent for a period of 2 years. Now, another problem is how much time will rupees 17,000 becomes 22,100 at 10% per annum simple interest. Again, the same thing is that the time is being asked. You have principal of 17,000. Your amount is 22,100. Keep one thing in mind. Principal is always less than the amount. The number which is bigger is always an amount because amount includes principal plus interest. Your amount is 22,100. Your principal is 17,000. Your rate is 10%, that is 0.10. You have to calculate the time. In this case, this time comes out to be 3 years. With this, I will be stopping over here. Now, I would like that any one of you has some confusion or some doubt about the topic because your derivative and application of derivative in business and this part, the calculation of interest rate principal are very important for your curriculum. Any questions from anyone? Yes, please.
I wanted to find out if it's possible for us to go through functions that's rational and algebraic, depending on your schedule. Maybe we can create time so that we can just revise. Because I've been trying to practice and go through them, but I'm still having some areas where I'm lacking.
Have you understood the concept or you want that I should continue more with it? I don't have any problem in taking up a class for differentiation again. Is the part for differentiation is the part for the differentiation is have you understood the part of differentiation?
Yes, for differentiation, I've understood, but when it comes to solving, there are some parts where I'm lacking. So I feel solving more questions and just doing a bit of revision, not that you have to explain everything, but solving more questions would really be helpful.
You try to solve problems which is given in the course material, and if you have any problem, so in the period of when we have class, you can ask.
All right, thank you so much.
Anyone with this? Can we conclude today's session? With this, I'm concluding to this session. Thank you. Bye bye.
All right,
Thank
thank
Thank you
you.
very
Bye
much,
bye.
sir.
thank you, sir.
Ok, to wanda nake so amfani da shi ina so in kunna TV, fanka ta sama, ina tunanin a bashi a kunna guda biyu misali, akwai guda biyu ta sama, sai ƙwayaye ɗaya, biyu, at least ƙwayaye guda biyar. Okay, it's just a rumor. Stop sharing it. You have to get confirmation before you share the rumors. On my own side, I don't see something else like that. Now, okay, how good. There is no problem. You can continue using it if you already have it. Don't. Papa, a ce zai kira gaban a kasu minti? Minti za kawo.